So here is part 2 of our carbohydrate lecture, and today we're going to be focusing on lipids. So to give you guys a preview of the word lipid and to make a nice connection, if you go to this doctor to suck all the fat from your body, that process is called what? You should be saying to yourself, liposuction. Well, it's a suction of the lipids or the fat. So fats are lipids, but also there's another molecule that are oils, and those are also lipids as well. So that's the group we're taking a look at. So the composition of these guys is going to be hydrogen and carbons. They are hydrocarbons. If you remember from the previous chapter 22, we took a look at hydrocarbons from methane to ethane to propane and butane, and those all contain carbons and hydrogens. What was the function of those hydrocarbons? That's the importance. Well, these are burned as fuel in automobiles, the hydrocarbons that we burn, but also in our bodies, this is when we're using them for respiration. So we get energy from these guys. So we can get energy from the lipids. We can also store these lipids if we're not using them. If we're taking in too many calories, our body will then store our calories as lipids, as fats. And then also lipids are found in membranes because if you remember from biology, we have these molecules called phospholipids. But also lipids are our hormones. And we'll be taking a look at hormones such as cholesterol and testosterone and estrogen. Some examples, we have our triglycerides. And our triglycerides are oils and fats. If you remember, when we made soap, we were using triglycerides. They have these 3 carbon-hydrogen chains, hydrocarbon chains, and that's why they're called triglycerides. That's our oils and our fats. Phospholipids look just like triglycerides, except they only have 2 chains rather than 3, and they have a phosphate head. And so it's a charged head that makes part of the molecule polar and attracted to water, and the other part is non-polar. We'll see this. Also, steroids have a very interesting shape to them. Here is our triglyceride. So if you remember again with the soap molecule, it looked like this. It had 3 chains. Notice how the chains are primarily made up of carbons and hydrogens. That's why they're called hydrocarbons. So the function of these guys, it stores energy between the carbons. So this molecule is going to be chopped up into small pieces, and it's going to be thrown into, if you remember from biology, the Krebs cycle. And the Krebs cycle takes in 2 carbon molecules. We'll take a look at those later at the end of this chapter. But look at how many carbon-carbon molecules that we have here. We're taking a look at these chains here. All of these carbon-carbon ones right here, etc. All these carbon-carbon ones right here. And all these carbon-carbon molecules here, these all are going to be producing energy. So we're going to take a look at the 2 types of hydrocarbons that we have, the 2 types of lipids. And the first one is called a saturated fat. Now, if you remember, we were looking at solutions, and saturated solutions were those that were full. We'll take a look at this molecule right here. What does saturated mean? Saturated means it's full of hydrogens. So in the these black ones are representing the carbons. So I'm just going to draw 1 carbon right here. And all these guys, these are the hydrogens. So I'm going to draw an H right there. So here's your carbon backbone, 1, 2, 3, 4, 5, 6. This must be hexane, surrounded by all of the hydrogens. But what I want you to note is that on this is that every carbon is maxed out with the number of hydrogens it can have. The carbons that are in the center, like the second carbon, can only have 2 hydrogens. The carbon on the end, over here on the left, it can have 3. We actually can't pack any more hydrogens on this molecule. So it's full of hydrogens. And I will show you what that means compared to an unsaturated fat in the next slide. So what type of bonds do these have? If you notice that they're all single bonds, the shape of this molecule is flat because it has those single bonds. And these are found in animals, and it's solid fat. So if you are eating butter, that is a saturated fat, and that's because at room temperature, that material is a solid. So I have a memory scheme for you to remember. We have a sat fat that's flat, found in a cat. That's your rhyme scheme. So all those things, they kind of rhyme and they go together. So it's a sat, fat, flat, cat, or rat, or bat, whatever animal that rhymes with at, you can put into there. So those are your saturated fats. They are solids at room temperature. They're single bonds. They're straight. Look at the next one. This is an unsaturated fat. Unsaturated fats are not full. And what I mean by this is if you look at the picture down below, I'm going to draw in right here. Notice how there's a hydrogen missing in that spot. There's a hydrogen missing here, and a hydrogen missing here, and a hydrogen missing here. Well, why is that? Well, remember, carbon can only form how many bonds? 4. So here's your carbon over on the left again, with again your hydrogens. Okay, carbon has 1. Okay, and I'm going to try to highlight these so you can kind of see them. It has 1, 2, 3, and then 4. So that's the 4 bonds. Okay, if you notice and you count, each of those carbon has 4 bonds. But because we have a double bond, that means it's taking away the opportunity to have a hydrogen there. That's why the hydrogen is lacking in these blank spaces. There's no hydrogens here, and there's no hydrogens here because the carbon has already found enough bonds and it doesn't have any space for those hydrogens. So unsaturated fats are not full. Bond type, we see that we have double bonds. And the shape of this, it causes it to be bent. Now I'm going to throw you back to an earlier lab that we did. We were playing with the molecules, and I told you to remember this time right now. I think this was half a semester ago, or maybe even it was last semester. If you remember, we tried to form this molecule called carbon dioxide with 1 carbon and 2 oxygens. And we tried to form it with single bonds, and we couldn't bend the bonds enough. And we actually had to bring in and switch the bonds to the double bonds, which were the flexible bonds. If you remember, what a double bond does to the shape is it causes the molecule to, that actually causes the bond to be bent. So if you notice how this molecule is not linear anymore, we have 6 carbons. It's not linear though, it has these bends to it, and it's because of the double bond. These are formed in plants, and these are your liquid oils, like your olive oil, your peanut oil, your sesame oil. Any oil that comes from a plant is going to be unsaturated. So again, it's the double bond that makes it look like this. So in saturated fats like butter, the straight chains, they all lay down on top of one another. And so they can lay down flat. But these guys have enough bend to them where it prevents them from lying down flat. Because they can't lie down flat, they actually begin to rotate around each other. And because they're rotating and moving, that means they're going to be in the liquid phase. So we have unsaturated fats, double bonds, bent, and those are oils. So take a look at that molecule at the bottom. We have is this an unsaturated or a saturated fat? Well, the top 2 chains are actually saturated. You can see that in right here it says saturated down below and saturated. This third one is unsaturated, meaning that it has a bend to it. So this is going to be an oil, but notice how only one of the 3 is going to be unsaturated. So it's called a monounsaturated. One of the 3 chains of the triglyceride is now unsaturated. So monounsaturated fats, this is when one chain has a kink. That's what we see down below. Polyunsaturated fats means that you're going to have either 2 or all 3 chains. So more than one chain is going to have a bend to it. The critical importance of this is the more bent that it is, the more fluid it is, the more oily it is, and the more healthy it is actually for you. So if you're looking at a food label and you're looking at your fats, saturated fats are the ones that are typically more unhealthy for you, and the saturated fats the unsaturated fats are the ones that are found from the oils. Those tend to be more healthier for you. And not only more healthier for you, but if you have a polyunsaturated, that will be even more healthier than a monounsaturated. So in terms of health, it is polyunsaturated, monounsaturated, and then it goes to your saturated after that. Artificial hydrogenation. You might have heard of this before, and this is going to be up to you for the rest of your life to choose foods, and some of them have what are called hydrogenated fats in them. And the label will say contains less than 2% hydrogenated fats in them. But I'm here to tell you hydrogenated fats are bad. So what will happen when oils that are unsaturated are hydrogenated when hydrogens are added? Okay, so imagine that you have your unsaturated, okay, which is an oil. This has spaces for you to potentially put hydrogens. They're artificially hydrogenated, meaning they chemically add the hydrogens, and what happens is it loses the double bonds. So because it loses its double bonds, it's going to look like a saturated fat, even though it came from a plant. And so it's going to behave like a solid. An example of this is Crisco, and a lot of people use Crisco for cooking. Crisco is actually a plant-derived product, which should be an oil, and they've artificially changed it to take out the double bonds, and they put in the hydrogens. Those hydrogens, again, removing those double bonds, makes the chain behave as if it were flat, and it makes it behave like a solid, which is good for cooking. Unhealthy for you. And that leads to what are called trans fatty acids, or TFAs. And a lot of fast food places used to be cooking with these trans fatty acids, and I believe that they are now banned. It's against the law to be cooking with your trans fatty acids now. So if you can look at the bottom picture, we have what's called cis and trans. Notice how we have a double bond on the top, okay? We have a double bond in the bottom. But what I want to point out is the orientation of the hydrogens. Okay, this hydrogen is here, this hydrogen is here. Notice how they are across from each other and not on the same side. Trans, like a transatlantic flight or transatlantic voyage, goes across the Atlantic or across the whatever you're going. Cis has the hydrogens that are on the same side, and these are actually the common molecules that we have in our bodies. Trans fats are things that are not really recognized by our body. So these are the ones, the cis ones occur naturally. The trans fats are the artificial ones that occur when you hydrogenate something. So hydrogenation produces what are called trans fatty acids, which are bad because they produce higher amounts of bad cholesterol, which can collect in your arteries and lead to a situation called arteriosclerosis. Okay, and so what happens is, if you remember, these used to be hydrogens here. Okay, so I'm going to try to draw on these hydrogens. So we previously had these hydrogens right here and right here. And then we chemically come along and, or actually we're taking this oil and we're jamming on these hydrogens, okay, like this, to make it into a fat. However, as part of the process, it's not a 100% process. What ends up happening is a small percentage of the fats do not become completely hydrogenated, and they are partially hydrogenated, and it produces this molecule, which is the trans fat. This is the one, again, that is bad for you. So if the process of hydrogenation was complete and you can have 100% hydrogenation, we would not be producing trans fatty acids and Crisco would be healthy for you. Unfortunately, a small percentage have this transfiguration and it leads to arteriosclerosis. So saturated fats like butter, however, also increase the bad cholesterol in some cases. So is it better to have a product with trans fatty acids or is it better to have the saturated fat with the butter? I would actually say go with the butter. The butter is going to be healthier for you. However, there are a lot of products now on the market that are containing what are called palm oils. And palm oils can be solid when refrigerated. If you let it sit on the countertop, it might turn into an oil, but as a refrigerated product, it will stay as a solid. And a lot of foods now are using these palm oils because they are natural, they don't contain any trans fatty acids, and a lot of people use them on their toast for the butter substitute spreads. Okay, this is a monster. This is a molecule that was created, I think it was in the 80s, to satisfy people's desires to have a low-calorie potato chip, and it's called Balestra. Okay, this is an artificial oil that's indigestible by the body. Now take a look at this molecule. I'm going to try to highlight some of its features here. Okay, here are the center of the molecule. It has one chain, it has two chains, it has three chains, it has 4, 5, 6, 7. I think there's even an eighth chain. Maybe I missed one right there. An eighth chain on there somewhere as well. So normally triglycerides have 3 tails to them. This has 8. This is a monster lipid that's not recognized by your body. But in some cases, that sounds kind of good because it's indigestible, meaning that you can eat it and you'll get the oily sensation of a potato chip, but you will not get the calories from it because your body can't digest it. It sounds good. So it came out in the late 80s or early 90s, somewhere around then. And people at first, they were agreeable with it because they were able to eat their potato chips and not gain weight. And they become a couch potato essentially and eat whatever that they wanted. But there was a negative effect of this that was unseen. This oil is not broken down by enzymes and it goes right through your body. That's another picture of what this molecule looks like chemically in a 2-dimensional. So there are 2 negatives why this is wrong. Negative number 1 is this absorbed nutrients that were intended to be attached to real fats and it exits your body. So it was actually acting as a sponge, sucking up the nutrients for your body that were intended to go into your body. So it was taking away those positive things away from your body. So that's the first negative. Second negative, people complained about anal leakage. If you recall, this is completely indigestible. If you pour oil into a pot of water, what happens to it? All the oil coagulates into this one giant mass in the center of your pot at the top. That's what was happening in people's guts. Since this oil was not digestible, it was accumulating as one giant glob in their digestive system. And people actually had no control over when it came out of their body. So a photo will not be provided. Okay, and the last of the lipids, this is returning back to biology. This is a phospholipid. So imagine that you have a triglyceride. I'm going to go to the picture down here. You have 1 carbon, 2 carbon, 3 carbon. This is your backbone. This is your glycerol molecule. Here you have 1 chain. Here you have a 2nd chain. Oh, we're missing the 3rd chain. Well, we've taken that 3rd chain and we've replaced it with this phosphate molecule that has a charge on it. So its structure is a phosphate head. This is the one that reacts with water because it's charged and therefore it's polar. And it has 2 hydrocarbon tails. Those are the ones that are the nonpolar. And it forms these, what are called the bilipid layers, where the heads are facing the watery environment because they're hydrophilic, and the tails, they hide away from the water, and so they are facing each other. Where do we find these? We find these guys in cell membranes. So cell membranes are really just modified triglycerides.